Okay, thank you. Okay, thank you. Thank you to be here this morning. Well, my name is Henri Blondelle. I'm one of the co-founders of a small startup named AgileDD, and our purpose is to help you creating structured data from unstructured documents. Yeah. We have seen together that for today, there are two types of data, two types of documents you are dealing with. The good one, the one which are ready for nice analytics, and the other. And the other, we are not naming them the bad one, we are naming them the unstructured one. And are you really sure that these documents are ready to create value in your organization? Yes, maybe not. But for the time being, first question I would like to ask you is how much do you consider of these documents in the documents you are working with are structured or unstructured in your organization? And because we have learned for today that we are not anymore geoscientists but geodata scientists, we are not to solve this problem using an Excel or something else. Since we are data scientists, we will use the social media. And I would like to do that with you right now. So I have a question for you, and we have learned yesterday that our best tool is something like that, no? So I would like you to use this one and reply to this question. What are my ratio of structured and unstructured data in my organization? So please go to, sorry, we are not seeing the same thing. Okay, so we'll not use that. I will just ask you the question. According to you, how much of this document do you have close to you? Is it something like 10% of unstructured, 20, 50, 80% of unstructured? What is your estimation? I wanted to do that with Mentimeter, but unfortunately it doesn't work here. So, 80%? Probably. Any other answer? Most of the people who have been working on this issue are saying that yes, it's approximately a ratio of 80% of data you have, but which are not ready for modeling or analysis. Is that really important? Until recently, it was not so important. We skip that. It was not so important because there was close to you some nice people, the data manager, who were spending their time extracting the information you need from your unstructured document in order to create some corporate database, some project database, whatever you need, in order for you to consume this information. The point is that recently, those people have started to disappear. You know, remember yesterday we have learned that we have to cut some cost in your organization because of the price of the whole or whatever. And this population has decreased. And so now we have here a bottleneck. We have plenty of new tools to analyze the data, but we have less people to extract the data from our structured documents, which are the majority of the documents we are dealing with. So our purpose at AgileDD is trying to help you facing this issue using machine learning tools. So we use machine learning not to analyze your data, but just to create data for you. So let's see what does it mean exactly extracting data and trying to reverse the ratio to make 80% of your data directly available. On a small formation evaluation log like this one, that means that to be able to recognize a well name, to recognize all the well header metadata, also to recognize the mnemonic of the log, which are displayed at the bottom of this PDF, to recognize the logs themselves directly, to extract the value which are displayed there, to recognize some symbols like the lithology here or the show here, but also to recognize that this particular paragraph is about description of lithology and trying to understand this lithology in order to move this information to your place of consumption. I'm not saying that we are able to do that magically today. We are still facing some difficult document to crunch. But we are developing a learning model in order to do that. If we can do that, the advantage will be to save money, yes, to decrease your cost of data indexing. But the more important is that allow you to go faster, to be able to crunch thousands of documents in a couple of days to extract the information you need. Sorry. And if you can do it at a lower cost and faster, that means that you can do it on more documents. And you can bring more information to your analytic tools. To be honest, we are not the first to do that. You know, I said at the beginning that the data extraction is mainly a problem of human resources, not really. In the past, thanks to the OCR and thanks to the full text indexing, we have started extracting automatically some information. But there are information which are difficult to extract. Just think about the numerical value. You know, it's very difficult to extract automatically the well depth, or the total depth of a well. Why? Because we are using very unstructured information. In addition, we are not so clear about the taxonomy we use. We are not so clear about the ontology we use. Total depth may be a total depth for logger, for driller, can be written TD logger, a lot of variation. And that's the power of the machine learning. If a machine learning can recognize, distinguish between a cat, as we have seen this morning, and a dog, or a bicycle and a truck, maybe a machine learning can distinguish between a surface coordinate and a TD coordinates. And we are training the machine to recognize between these two distinguished features. Let's see an example. That's the interface we provide with the tool. So we have performed an extraction of information from a bunch of documents like that. So it was something we did for the CDA last year. So there were a mix of logs, of reports, of Excel file, of TIFF file, PDF, everything. And the first things we have done is trying to detect which kind of document it is. So for that, in machine learning, there is a tool named semantic analysis. So you have a kind of global reading of the documents, an analysis according a taxonomy you provide. And so after learning, the machine can recognize, in this case, the machine has recognized that this document is a geological petrophysical documents. We have been using the CDA taxonomy for that. It's CS8 taxonomy. So we have trained the machine to do it. In this case, for this document at least, it seems to have been working correctly. After that, we can also detect some particular information, particular keywords or metadata, such as the well name, the operator. And the beauty with that is because we apply a statistical approach to detect this information. Not only we detect the value, which is what was the first purpose, we also able to source the value, so we keep the link between the extract value and its location in the document, so we can tell you this information comes from this particular document at this particular place on this particular page. And also, we are able to associate a confidence factor to the information we extract. In this case, we have been able to say that this operator has a probability of 63% to be the operator. Okay. So we are able to measure the accuracy of what we do. So you can extract anything you want. You create one model per metadata you want to extract. Sometimes you receive some alert. Because we have extract the well name, we are able to index the document per well name, per entity here. And so we just alert the user that for the well result, according to the documents, we have not only one value, but several values. So that's the reason sometimes you have an histogram like that. So it's another, in addition of the confidence factor, it's an alert telling you all your documents are not saying exactly the same about this metadata. How it works? It's machine learning, so they need two main processes. First one is about training. So you need an handful of documents. These documents will go through an OCR, and because they are sometimes a little bit complex, we need a pre and post OCR around it. After, you have two ways. Either you ask one of your remaining data manager to tag the information for you, or if you have a database you trust, you can input this existing information in order to create what we name labels, example of the truth, or as the opposite, example of error. But, you know, we have seen with a presentation from Statoil just a few minutes ago that you need a lot of labels in machine learning. That's an issue. You need to train a lot. So in order to reduce this effort, we have developed a tool to, let's say, extend automatically the training you have done. I will take an example. Imagine you train on a document that the TG is 3,200 meters. Okay, so you will highlight this value on one, maybe two documents. But if there are several documents associated to your well, it's possible that the value 3,200 will be found. And so we do that for you, and in order to save your time training the algorithm. When we have the full collection of labels, we can ask to create the model. So there are several methodologies we have seen. We use only supervised training method, but there are several methods for that. And we create one learning model per keyword to be searched. And that is, you have done the main things now. After comes the time for applying that to any number of documents you want. So you will apply the same OCR process, obviously. we will, thanks to some classical data mining method, we will extract what we name candidate to be a value. So, for example, I will take again my example of the total depth. If you are looking for total depth in some documents, we will propose as candidate any numerical value in a range. Okay, and all these candidates will be submitted to the model, to the learning model, and so we will be able to write the candidates. And by a cutoff, we will keep only the best one. And we will, in the same interface we have seen a few minutes ago, we will expose those candidates. Here, for example, we have just take two information, the operator name and the well name. So we are able to locate the information. We are able to evaluate the confidence of this information. And a property of the machine learning, we haven't speak a lot about that until now, is that the machine learning are like the French red wine. It's improving with time. You know, if you still have a data manager to just say, I like this extraction, or at the opposite, I don't like it's erroneous. Okay? If you can validate or refute some information, this action will be considered as new label and integrate in your model. And so next time your extraction will be better, closer to what you need. Okay, let's see that on a practical example. One of our customers wanted to see the change, the evolution of seismic design in a large area of the world, and he got 2,000 something reports. It was acquisition report, navigation report, QAQC report, HSE report about the seismic, and they wanted to know what has been the parameter for the acquisition design. So I mean, how many source, how many streamer, and so on and so on. Okay, and he wanted us to solve this, to reply to this question, but he didn't want to spend too much time on training. So he asked us to use our tool, which is a very generic tool, originally developed for working on well data, and he asked us if we could apply that directly on seismic data. We say yes, because for us, you know, any type of document is the same. It's just a matter of training the extraction. He wanted to have something more or less as good as what has been classically done by data managers, so an average of 7% of what we name false positive erroneous data, if you want, in the output database. So, which kind of information you wanted to extract? At first, the type of documents. So he provided a taxonomy, and the question was to distinguish between a project plan, a navigation report, an acquisition report, and sometimes, they are very, very similar. But the purpose was to detect the type of documents it was. Second type of information to extract was some information you can reduce by list. For example, if you are searching for a seismic contractor name, you can provide, there are some existing resources to provide some list of possible contractors with their synonym. I don't know, Schlumberger can be, which is no more a seismic contractor, but Schlumberger can be named Schlumberger or SLB or whatever. So you can, to help you to extract this information, in addition of the context analysis, you can input some dictionary and dictionary of synonym. So that was the case for operator name, contractor name, name of the vessel, type of acquisition, things like that. There were plenty of numerical value. Geophysicists like numerical value, so the design of the acquisition can be reduced by approximately 40 numerical parameters, such as the number of source, water depth, the number of streamer, and so on. And there were also some, what I've named, some difficult tasks. Yes, the geophysicists are very good for numerical value, but with alphanumerical values, they are not so good. Here it's an example of trying to extract the name of the acquisition, the name of the survey, and you can see the number of variations for survey name within the same document. According on the cover page, it was named Morocco 3D Reconnaissance Marine Seismic Survey. At the top of page 1, it was something else. At the bottom of page 1, there was another name. So you can see the nature here of what means exactly unstructured information. Okay, and so you have trained, but it's not so a big issue. If you have a lot of variation this way, the machine, little by little, if you input enough data, will finally recognize what is a survey name. So we start by training the machine, training for positive value, but also for negative value. You know, in a report, you have not only you don't have only one vessel name in a seismic report, because there is frequently a chapter about interference where there are some name of other vessels. So you have to train about what is the vessel name of this survey and what are not the vessel name of this survey. So you do some training, and we did it on, in order to be able to measure what we do. One of the methods for machine learning to be able to define the accuracy and precision of what you do is to, normally you should do a cross-correlation, but a simplest way to make a cross-correlation is to apply the hold-out method. So you split your document in three packets. The main one on which you will do some training, a small one of, in this case it was only 10 documents, on which you will test your model several times using always the same data to create a learning curve. And at the end, the customer wanted to do a final test by himself using a set of documents for a blind testing. So that's the result of the learning curve. So that's a way of, in 12 loop, I think, the way the machine has been improving, as can improve a data operator over the time to extract the parameter we wanted to extract. So at the beginning, with few training, you have a very low score, but little by little, and it's not always, sometimes, you know, your training are going in the wrong direction, so you are not improving, or you reach a plateau. And after some additional training, that means that you introduce some new information, you can improve. And finally, we reach the objective to be a little bit better than what has been done by the human for the same time of task. So it took 6 weeks to train the machine and measure the accuracy of the model. The curve I gave you, it's an average. You don't have exactly the same curve for all the attributes, for all the metadata. There are some metadata which are, let's say, easy to extract. The numerical value were quite, in this case, were quite easy to extract because they are well described in the documents. You know, frequently the value for the volume of the source, you have something like volume of the source column or gun volume column, and it's straightforward for most of them. For
3 minutes.
Thank you. For the alphanumerical value, there were some which were easy to extract because you can apply a dictionary, but there were some other which were difficult to extract, like the survey name. We have seen that together at the beginning. It's something, very unstructured, and we were progressing, okay, but with only 60 documents, it was not enough to have something stable and something which give you the good survey name over than one, or more than one time over two. So you need for this one and this one, you need some more training data. And sometimes we remain for example, a very simple information like the starting date of the survey. We were very bad. Why? It's because sometimes you don't train correctly the machine. I did the training myself in this case. I can tell you that I say, okay, what is exactly the starting date? Is it in some survey, it's a date of the first shooting. For some other surveys, the day the vessel leaves the harbor, and so on. So I've confused the machine with all this type of dates, and the result, when you don't train correctly the machine, you don't have some good result. But in general, it was okay. That's the result of the blind test performed by the customer, in line, more or less, with a learning curve. A blind test is frequently got some slightly lower result. Why? Because when you measure always with the same data, with the same document, you introduce a bias because you observe some mistake, and so you will introduce some new training to correct those mistakes. So it's very important to make a blind test at the end to have a final measurement of your accuracy of precision of model, in addition of the training curve. So what has been learned for us? First, it's possible to apply some very generic tools such as semantic, SVM, or forestry to index unstructured documents, extract the data you need. With some few weeks of training, the accuracy can be similar to what is done by a human agent. But you don't extract only the value, you extract a probability of a confidence on your value. You are also able to source the value. You know from where it's come. You know also if all your documents are not saying the same thing, you may have an idea of the variation for the same information according to the documents. You can measure the accuracy of your model, and you can use your model for several purposes. If you have trained something to extract a whale name, okay, your training can be reused to extract a survey name. If you have trained something to extract a total depth for a whale, you can reuse this training to extract a water depth. Could that be useful? I hope so. Can be useful to populate some corporate DB. Can be also useful to QC a database, because we can recreate the link between your information and the source document. If you have a document management system, we can populate some additional descriptive metadata to it, reading the documents. We can help you to initiate some projects, and maybe in the future, more important, we can provide information to your new analytical tools. Sorry. That is.
Thank you very much.
Thank you.